AMiBA, ba, 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 ba. The Yuan-Tseh Lee Array for Microwave Background Anisotropy, also known as the Array for Microwave Background Anisotropy, AMiBA, is a radio telescope designed to observe the cosmic microwave background and the Sunyaev-Zel'dovich effect in clusters of galaxies. After completion of the SZE campaigns, the telescope has been repurposed to study the evolution of molecular gas throughout the history of the universe. It is now referred to as the Yuan-Tseh Lee Array YTLA. It is located on Mauna Loa in Hawaii at 3,396 meters, 11,142 ft above sea level. AMiBA was originally configured as a 7-element interferometer atop a hexapod mount. Observations at a wavelength of 3 mm 86-102 GHz started in October 2006, and the detections of 6 clusters by the Sunyaev-Zel'dovich effect were announced in 2008. In 2009, the telescope was upgraded to 13 elements, and it is capable of further expansion to 19 elements. AMiBA is the result of a collaboration between the Academia Sinica Institute of Astronomy and Astrophysics, the National Taiwan University, and the Australia Telescope National Facility, and also involves researchers from other universities. Design. AMiBA was initially configured as a 7-element interferometer using 0.576 mm Cassegrain dishes mounted on a 6 mm carbon fiber hexapod mount. It is located on Mauna Loa, Hawaii, and observes at 3 mm 86-102 GHz to minimize foreground emission from other, non-thermal sources. The telescope has a retractable shelter made from 7 steel trusses and PVC fabric. The receivers are based on monolithic microwave integrated circuit AMiC technology, with low-noise amplifiers cooled to 15K, which have 20 GHz bandwidths and provide 46 dB of amplification. The signals are mixed with a local oscillator to reduce their frequency prior to correlation with an analog correlator. The system temperatures are between 55 and 75 K. AMiBA started in 2000. With funding for 4 years from the Cosmology and Particle Astrophysics project of the Taiwan Ministry of Education. A 2-element prototype was set up on Mauna Loa in 2002. Further funding for a second 4 years was provided by the National Science Council. The mount arrived on site in 2004, and the platform was installed in 2005. The first 7 elements were then installed AMiBA S7, and the telescope's first light was in September 2006, observing Jupiter. The telescope was dedicated in October 2006 to Yuan-Tseh Lee. The array was upgraded to have 13 1.2 mm dishes in 2009 AMiBA A13. After extensive testing and calibration, scientific observations resumed in 2011. It is further expandable up to 19 elements. SZE Observations. The primary goal of AMiBA is to observe both the temperature and polarization anisotropies in the cosmic microwave background at multipoles between 800 and 8,000 corresponding to between 2 and 20, as well as observing the thermal Sunyaev-Zel'dovich effect in clusters of galaxies, which has a maximum decrement around 100 GHz. In its initial configuration, it measures up to multipoles of 3,000 with a resolution of around 6 arcminutes. The telescope only observes at night during good weather, using planets for calibration. 6 clusters were imaged in 2007, the Able clusters 1689, 1995, 2142, 2163, 2261, and 2390, which have redshifts between 0.91 and 0.322. For the largest and brightest 4 of these Able 1689, 2261, 2142, and 2390 comparisons were made with X-ray and Subaru weak lensing data to study the cluster layout and radial properties, specifically of the mass profiles and baryon content. 13-element results from the YTLA were published. Intensity mapping of molecular gases. The YTLA has been repurposed with the goal of detection and characterization of molecular gas at high redshift through the technique of intensity mapping. Molecular gas, which is primarily in the form of the hydrogen molecule H2, is the material from which stars form. Understanding the gas content and evolution throughout the history of the universe informs astronomers about the processes of star formation and galaxy growth. Unfortunately, cold H2 is not easily detectable. Carbon monoxide CO is commonly used as a tracer of H2. The YTLA uses the technique of intensity mapping IM to study molecular gas. Rather than attempting to detect individual, distant and faint galaxies directly, the YTLA measures the statistical properties of many galaxies over a very large volume. Although it is much smaller than powerful telescopes such as ALMA and the VLA, the YTLA can provide critical and unique information on galaxy evolution. The intensity mapping technique is used over a wide range of wavelengths. An upgrade of analog and digital infrastructure at the YTLA was necessary to enable IM. In particular, a digital correlator based on Casper technology and the Asia-developed 5GS/S sampler were developed. The digital correlator produces 2x2 GHz bandwidth in each of two polarizations for 7 antennas. Collaboration. AMiBA is the result of a collaboration between the academia Sinica Institute of Astronomy and Astrophysics, the National Taiwan University, and the Australia Telescope National Facility. It also involves researchers from the Harvard-Smithsonian Center for Astrophysics, the National Radio Astronomy Observatory, the University of Hawaii, the University of Bristol, Nottingham Trent University, the Canadian Institute for Theoretical Astrophysics, and the Carnegie Mellon University.